Welcome everybody to a session from DWP Digital on building a service-driven data ecosystem. I'm just going to take you through a little about who we are and what we're trying to achieve and what a data ecosystem is, and then I'm going to be handing over to Daniel Routledge, who's going to take you through how we're going about it. So a little about who we are. I'm Alison Wonderland. I'm a lead product manager with the Department of Work and Pensions, and as I've mentioned, Daniel's joined us today. He's a data scientist working within digital as well. We work within digital focused on services that support people with a health condition or disability, and our scope includes around 45 benefits and grants that provide support to millions of people each year. So what are we trying to achieve? DWP Digital published a blog in May 2021 that set out goals for the next year. We have 4 goals, and they are delivering great services, building new user-centered products and services, using new technologies and data to innovate, and building our capacity and capability. In today's session, we're going to focus on goals 2 and 3, as they're the key focus of our teams. So for people with a health condition or disability, we know that often they don't understand what support is available to them. They can find it hard to navigate through the different benefits and grants that DWP offers, and they find our processes confusing, and they often don't understand the decisions that we make. Our vision is that people with a health condition or disability will get the support that they need. And our mission is to provide simple, responsive services and make timely, accurate and understandable decisions that help people get the right support. It's a complex area, and we know we can't achieve that vision overnight. We want to design our services based on our users' needs. These users range from the people who need the support, the people and organisations that support them, as well as our internal agents who administer the benefits and grants. Our challenge is how we find that meeting point between how we best meet those user needs and what is possible from a government and DWP perspective. So why a data ecosystem? To enable us to understand user needs and to measure our progress as we transform our services, we need to use data. That's both qualitative and quantitative. As you can imagine, with the number of benefits and grants, along with the number of people who receive them, that's a lot of data. At the moment, it's hard to see our users in this data so that we can use it in a meaningful way to identify and explore our users' behaviour and understand their needs. On screen now, you'll be able to see a journey that's based on some research that we've done that clearly shows that DWP only supports part of a citizen's journey. The citizens focused on their goal, in this example, of their life returning to how it was before they got cancer. They're not concerned with what DWP is trying to achieve. So we need to design our services with this understanding and this broader context to look for opportunities to reduce the burden on the citizen and help them get the support they need so that they can focus on their main goal, which is their health and getting better. The data we currently have is not gathered in a consistent way or stored in a way that makes it easy for us to connect it together to give us the insight and information that we need. This is where a data ecosystem can help us. It will enable us to bring together data from many different sources and use the data to generate insight to help us design our services and inform future policy design. It will enable our teams to analyse large volumes of data to learn about our users and services, view granular real-time insights about the services and monitor their performance accurately, use data to make recommendations to support decision-making, and develop analytical models and embed them into our operational systems. All of this is so that we can use that knowledge about our users and services to drive continuous improvement, spot when the services don't work well for our users and respond quickly, improve journey times through automation, empower our staff to focus on the tasks that require empathy and judgment, and build services offering tailored journeys and better user experience. So now I'm going to hand over to Daniel, and he's going to take you through how we're actually going about this, which is the far more exciting part.
Let's talk. So thanks, Alison. So I'm going to talk a little bit about how we're building it. Now we understand a little bit about why that is. And, you know, the question is kind of, well, where to start? And I think one of the best places to start is an example of how we would use kind of data to measure a service. So we base everything that we're doing around these mission statements, the mission statements that were mentioned earlier. And this is one of them. So, how can we use data to measurably improve the services? That's a big use of the data. And an example of that is performance measurement framework. So what kind of data do we want? Well, it's the data that supports these. So we start off with those mission statements and think about design hypotheses. What kind of features do our teams want to build, and what kind of impact do we expect those features to have? We then think about what kind of metrics we could use to support whether those impacts have actually happened, whether we can see if the features have had the kind of effects that we want. And then once we understand what metrics we need to measure those, then we can start thinking about what data is necessary to provide those metrics themselves. This performance measurement framework kind of has two bits of data in it. It has the metadata data in it, describing how we kind of do the testing ourselves, and then the data itself, which sits behind those metrics. So we need an ecosystem that caters to both of these. This is an example of kind of data from a service. So performance metrics and measurement are data that we extract from a service to perform a particular goal. There's different flavors of this, but other ones in data from a service will be things like analytical insights. So if we can take data and look at it for anomalies, unusual things, unusual patterns, then that's another kind of example of taking data from the service to solve problems. Governance and transparency data is also data from a service, so making sure that data is secure, making sure it's only retained for as long as it should be retained, that kind of thing. This is data that we extract from a service to try and meet needs. Data in a service is a different kind of flavor again, so this is where the data doesn't really leave a service and come to a platform. It stays within the service in the ecosystem. So this is where we look at things like embedding responsive kind of decisions in the service. It could be something as simple as saying, in a health assessment, for example, if the assessor is doing the assessment over the phone, then there will be questions about physical examination, that assessment, that don't need to be asked anymore because it's being done over the phone. So it can take the data about what type of assessment it is and tailor the questions based on the data that it already has. So that's kind of an example of where the data stays within the service to make that kind of loop. Intelligent alerting is also something that's useful there. So if, for example, in a similar context, if an assessment was in progress, but it's taking an unusually long time to be completed, then we can maybe embed something that can automate the alerting of that. And the users themselves, they would want to be able to monitor their own progress. That's an important target in health. And we want to make sure that the data that they're inputting actually tells them how far through the journey that they are, so that they know what's still left to do and what they've already done. So they can feel reassured that they've completed what they need to. A couple more flavors as well that are more relevant to some of the data ecosystem stuff that we look at as analysts. So data for the service is where we take data and actually produce it. We author it and make it available to other people to solve their problems. That could be something like using some health and disability data to make available information to the people who give off those like blue parking badges. So making sure if the service user gives us permission to use their data in that way, that information is available to third parties. And we treat our own internal services in a similar way as well. So sometimes we produce data in one service that can cater to another one. This is so that people who are using our services only have to tell us things once. They tell us in one service, and that can pass that same information to a different service. And data as a service is a thing as well. So if, for example, you're using DWP's Check Your State Pension service, then you can go online, input some details about yourself, and then get data back, which is information about when you're eligible to claim your state pension. So that kind of thing. Different flavors of getting data. This is how we use the data. But we've got challenges there about how do we make that data available in a quick way? How do we make it usable to those various different users? And this is one of our mission aims. We want it to be available instantly. We get it from a diverse range of sources. So we've got some older systems like Job Seekers Allowance, for example, that has services that are built on DWP-owned servers. So that's a kind of classic traditional way of getting the data. We've got some services that are built on the cloud now, so things like the Apply for Personal Independence Payment, that's on the cloud. And it's a similar kind of style data that we've gotten in the past, but that comes with administrative metadata as well. So how are those services used, for example, by our agents? Are they spending long time on one particular page, or are they moving on to different pages? That's a different kind of data source that's relatively new in the grand scheme of things that we're able to get out of the cloud stuff. And also the process metadata as well. So there's some of the stuff I talked about earlier about the measurement frameworks. That's process metadata that we can use to understand how we're testing our own services, how we're thinking about our own workflows and processes to make them more efficient too. All of these different data sources come with a diverse range of different systems that sit behind them. So those traditional systems will be based on kind of government data centers and networking. That's all kind of wires and proper hardware-based approaches. We've got that cloud-based approach now as well. So we're using Amazon and Microsoft's AWS and Azure platforms to build these cloud-based services. We've got kind of third-party access to cloud-based services as well, like Google Analytics, that can give us information about services, which isn't so much about the infrastructure, but more about actually getting a service from a user there. And some of those things that we build ourselves, so services that we build for other departments or for ourselves, like GovUK Notify, which is a tool that all government departments use to handle communications with people who use our services, texts and emails and things like that. And the organisation data service as well from the NHS, which gives us, for example, information about GPs' addresses that we can use to kind of confirm with people who are claiming health-related benefits who their GP is. So lots of information there from lots of different systems that we have to work with. Once we get that data as well, we want to work with a bunch of different tools. So it might be from things like using programming languages like Python and R, using tools like JupyterLab and RStudio on kind of local devices on a MacBook or whatever, to things like interactive off-the-shelf visualization applications like ClickSense and Power BI that can allow us to kind of explore data relatively quickly and interactively in the cloud already. We can build in-house visualization products as well, so things that are a little bit more bespoke and specific to the problem that we're trying to tackle, things in a similar vein to the government's coronavirus dashboard, where we've got visualizations that are built in a kind of GovUK style with the same kind of design principles that are applied to all of our different services. When it comes to tools about actually doing some heavy computational lifting, we've got things like Spark, which is very scalable, and that's useful for the kind of very, very large quantities of data that Alison mentioned earlier. And also part of the workflow as well involves different tools, so using tools like Git to develop code, VS Code, we use Docker to containerize some of the prototypes we're building, CI/CD pipelines, so some pretty standard development tools, but we need to make sure that those tools are in the same place as we can put the data. That's when we come to things like having an actual cloud platform as part of the ecosystem. So where do we actually put the data? How do we get the data in there? And how do we get the tools in there? This is an example of our health cloud data platform. And this is based on Microsoft's Azure platform. We've got a bunch of different tools in there that are really useful when we've got the data there. The data comes in from a variety of different data bridges. So for example, from those on-premise DWP-owned servers or from different cloud solutions. And they get transformed and processed and then placed in the data lake. And this data lake is specific to just the health context. So we've got this data platform in health, but we might bring in other data sources only temporarily. So those data bridges, bringing in data from different health services. An example of that would be maybe the hit reply process that I mentioned earlier. That comes from Amazon, where we've got a bunch of different microservices that handle things like logins and account management and claim management. And we get data from them through a bunch of different AWS services across a secure data bridge that bridges the two different cloud environments into our health data platform. We've got other things as well, like PIP-CS, which is a kind of more old school legacy system that's based on DWP-owned servers. And again, we have a bridge that brings that health data into the health data platform so that we've got all of that health data in one place, the same place as the tools that we can use to analyze it. That's part of a data mesh model as well. So we have that one data platform that looks at our stuff, but actually that data platform can link to other data platforms. This is a bit of a decentralization approach because we don't have a kind of centralized warehouse that we would expect to push this health data to. And we just kind of manage and author our own health data. And if we need data from other domains within DWP, then we would expect to subscribe to them kind of directly. And likewise, we would want to make sure that our data is available to other domains that might benefit from it elsewhere in DWP. That can be something as simple as if there's eligibility criteria about different benefits. If they need to know if somebody's already claiming a disability benefit, then hopefully we'll be able to answer that question with a simple API that's sat on top of our health data platform. Key principle in the mission statement is that we would want people to only have to provide information once. And part of that, part of the whole ecosystem is making sure that standards are in place. So if we wanted to have those different domains talk to each other, then we need to have formats and interfaces that are interoperable and reusable. That standard is really important across the board and making sure that everything that's linked together is linked together in a reusable way. If things already exist somewhere, then we want to reuse those components. Engineers might have already solved the problem that we're trying to solve, so let's try and reuse things as much as possible. Linkable identifiers as well, so if we're trying to match data sets across different domains, health and, for example, pensions or health and some working age benefits, then we want to make sure that the data sets are using common identifiers so that we can link those things together. And also we want those data sets to be discoverable to people outside the domain as well. So what kind of data do we actually have hosted on our health data platform? What kind of things does that include? Can people in different domains find that easily? Do they know what we've got? Once they find it, is it understandable too? So do they understand what that data set is actually about? What does it cover? What's the history of it? Which source system does it come from? Who owns it? That kind of contextual information that makes them understand the provenance of the data and kind of help them to trust it a little bit more. And on the subject of trust, privacy and security is really important as well as a standard. We want to make sure that when we're moving data across cloud platforms, from on-premise to into cloud, and between different domains as well, security and privacy is really important. So data retention is important. We want to make sure that encryption of data is important. And it's one of the core principles that underpins everything. Data standards, along with the framework stuff, the different uses of data, the different systems, and the different ways that we link things together, all form this ecosystem. So we've got loads of different ways of using data, loads of different sources. We want to bring it together into a platform with the tools so that we can reuse it and solve the exact kind of problems that Alison mentioned earlier. So that's pretty much it for me talking about the actual platform itself and the kind of tech side of things.
So I'm Karen Elliott. I'm a senior lecturer in FinTech in the business school, but I'm also I also lead the financial inclusion and inclusion projects with the business at the computer science school as well. So what I'm going to talk you through is just the project that we've been working, and links to what the DWP are doing around dealing with people who perhaps on the marginalized aspects of society. So where we started from with our research was to look at verifiable credentials. Some of you may know about verifiable credentials, but we wanted to look around the fintech aspect. And FCA brought out this table that you can see around the 4 key drivers of the characteristics of vulnerability. Now, this might become more interesting as we get later into the year when the actual furlough scheme ends and more people will actually find them at these sort of things. A life event, you could lose your job, it's a breakdown in your health, etc. And this led us to think about, if somebody was trying to get credentials, we all know if you want to open a bank account, usually you would use 3 types of credentials. It'd be your passport, your driving license, and utility bill. However, if you are in sort of the DWP category, if you lost your job, or you may have been homeless or suffered other life events or health events or anything across these 4 drivers, then you're going to be slightly different. So what we wanted to do is look at the basic process of verifying the credentials and then how we could help people use these. So we're talking about trust because, as I said, this is coming from our Finclusion project, but we've also got the FinTrust project running, which is looking at trust engineering into the fintech environment and technology. So the basic model around trust we've got here is we've got the holder, the subject, which would be us, and then presents to the verifier, which could be the NHS or etc., or a bank who's actually to verify your identification. So the verifier then goes to the issuer, which could be the NHS, as we're going to use in our instance, and then they issue a verifiable credential back to the holder, which, as we can see later, we've built a prototype where you can have this on your phone. So then next happens the architecture that sits underneath this, and Daniel was talking about the architecture that they're building in their ecosystem as we're looking at building a decentralized identifier and using a distributed ledger such as blockchain, but we're also exploring other forms of DLs. And so you can see the same process at hand here. The verifier requests proof of who we are. And then the issuer, the holder actually goes to the issuer and says, can you identify? So the NHS in this position would go through, find details of who you are, send it back to the holder. They send it to the verifier. And then the process works in this way. A little bit more in terms of creating a claim. So the user navigates the site to the issuer, say the NHS, and they say in our prototype, can you issue authorization to verify my ID? As you can see here, they generate a credential, they issue the credential, which we're using Microsoft Ion Authenticator technology. This displays then the accreditation, and then as a user we say we accept that accreditation and we store it on our phones. So we now got it on our phones that we've got a verifier credential saying that we are who we are. In this case we're saying the issuer is the NHS. Then you've got a verifier, say a financial firm, a bank, etc., wants to get to verify exactly who you are, and you can use the verified credential in this way. So again, you go to a firm, say applying for a loan or a mortgage or even a basic bank account. So for people we deal with who are perhaps the underserved or unbanked that we're looking at, this can work for them, where they will then request from the authenticator a verifiable proof of the vulnerability, which we are going to use as we're going to call it a fairness for all, as I'll show later in our prototypes. They need the vulnerability status, so they display the relevant credential to the user. They will then select which credential they want, and then they present it to the verifier. It's verified and goes back to notify that it's been accepted. So our prototype at the moment, we remove the label of vulnerable. Why is that? Well, as a sociologist and behavioral psychologist, I've been working with some charities and speaking to them about the label of being a vulnerable customer. And they prefer to say that they're in a vulnerable situation. And therefore, we decided we didn't like the name, and we wanted to say this is fairness for all. So this is what we've called it. As you can see here, using the ION technology, it looks like little credit cards. You can see this is a basic activated window here. No credentials have actually been used at first. So what we do then is, as we said before, the QR code. If you're issuing the flow, you start this by saying you want to actually access and start a verifiable claim. So here, this is a screenshot of how you go through the flow. You've got the empty wallet on this one side. You add in the credential, fairness for all. You have to sign into your, it's Microsoft backed, so Microsoft account here, but that could change with different options. You want to add the credential of fairness for all card, and then you say that you're going to add it and you've accepted that credential. Now, what happens when somebody wants to verify who you are? You have it here that we've just put here. Newcastle Research Bank is asking for this new permission to verify that the person is who they say they are. You allow it. It goes through on the activity, and it shows up that you presented your credential to Newcastle Research Bank. Now, at the moment, what the flow does is it presents actually the full credential. So say if it was an NHS, a letter to confirm your address and where you were going to for an appointment, it would display the full credential. What we're moving towards in this project as well, when the technology gets there, so Microsoft are working on it, is to actually display an attribute of that credential. So for instance, it could just say that Karen Elliott is able to live at this address, and confirm it yes or no. And so we're also linking this into the concept of corporate digital responsibility, because if we're looking as a DWP to create an ecosystem, we need to think about how we're using data, how we can use prototypes this to be co-created with people. So we're conducting interviews with the likes of the Astor Foundation, the Joseph E. Ramsey Foundation, to understand the perspective of somebody who's perhaps been homeless or had a serious life event or health event. So I'm sitting on the Prime Minister's Challenge Dementia group to understand what it's like to have dementia, how you navigate the system, whether it's DWP or a financial system, and how we can use a technology that works for all in an ethical manner and can be used to ensure that corporates are aware of what they're doing with and by the digital and data as part of their organization. So hopefully you can get the idea of what we're trying to do. They're moving towards the concept of self-sovereign ID. So what does that mean? That actually means by having this sort of wallet that we've got on here, we actually have control of our own data, and we can decide to share who the request with to a verifier who asks us for verification of who we are. We can actually decide who we're going to share our fairness for all details with. As I say, that will move forward, so you'll get an attribute of that credential, and that will be the way we're moving to. As it is, as it stands, we can't do that in full as yet, but that's the way the technology is flowing. Hence, this is a prototype funded through the Gates Foundation and the Turing Institute. So I just want to say thank you. It's a short presentation. If anybody's interested in what we're doing, it does link to what the DWP are trying to do around an ecosystem. There's a full team here. So Professor Advan Morsel, my colleagues in the School for Computing, and Tassos can't be here today, but he's actually my RA who works with me in this field. So if anybody has any questions around self-sovereign ID, or where we're going with the prototype, or any suggestions for improving the way we do the research, please do get in contact.